Hello and welcome to my channel. In this video we are going to solve 1 mark questions from coordinate geometry chapter which had appeared in CBSE board exam 2025. Now this video covers 12 questions and you will find each question along with its timestamp in the description box below. So let us start with the first question now. The midpoint of the line segment joining the points P -4, 5 and Q 4, 6 lies on. So for example, if we have a line segment PQ, in this we need to find out its midpoint, that is a point which is exactly at the center or in the middle of the line segment. So to find out the coordinates of the midpoint, we have a formula which is x, y, that is the coordinates of the midpoint, is equal to x1 plus x2 over 2, y1 plus y2 over 2. Now here we can consider the coordinates of P as x1 and y1 and the coordinates of Q as x2 and y2. So we have to just plug in the values of x1, y1, x2, y2 in this formula. So here we have written -4 plus 4 over 2, 5 plus 6 over 2. Now here -4 plus 4, they will add up to give us 0. So we get 0 over 2. So this will go down to 0. And the y coordinate is going to be 5 plus 6, which is 11. So 11 over 2. So here we have written the coordinates of the midpoint are 0, 11 over 2. But if you look at the options are given as whether the midpoint is going to be on the x-axis, that is over here, or is it going to be on the y-axis, or is it going to be on the origin, or it is neither going to be on the x-axis nor y-axis, means it could be somewhere over here or somewhere over here, anywhere it could be. So we have to understand from these coordinates where the midpoint is going to be. Now if you look at the x-coordinate is 0 and the x-coordinate is 0 on the y-axis. So any point you take on the y-axis, the x-coordinate is going to be 0. So here our midpoint is going to be on the y-axis, that is option B. So to find out which is the correct option, we have to make use of the coordinates by using the midpoint formula. Now let us move on to the next question. The line represented by x over 4 plus y over 6 equal to 1 intersects the x-axis and y-axis respectively at P and Q. The coordinates of the midpoint of the line segment PQ are. So here we have been given an equation for a line and it has been mentioned that this line intersects the x-axis at P and y-axis at Q. We need to find out the midpoint of this line PQ. So let us begin by rewriting this given equation. So x over 4 plus y over 6 equal to 1. Now here since it has been mentioned that the line intersects the x-axis, so for example if this is the x-axis, it is going to cut the line this way on the x-axis. So on the x-axis the y coordinate will be 0. So here we have written since the line is intersecting the x-axis, then the y coordinate is equal to 0. So if y equal to 0, then this fraction y over 6 goes down to 0. So we are left with x over 4 equal to 1. Now in the next step we are going to take 4 on the other side of equal to sign. So 4 multiplies with 1 giving us the value of x as 4. So the coordinates of point P are going to be x equal to 4 and y equal to 0. Now similarly we are going to find out the coordinates of Q. So here we get the point Q when this line intersects the y-axis. So when the line is intersecting the y-axis, it looks somewhat this way. So probably it's going to intersect like this because this is the y-axis and this is the line. So at this point the x coordinate is going to be 0 and we are going to have a y coordinate. So since the line is intersecting the y-axis, the x coordinate is equal to 0. So here x over 4, this fraction goes down to 0 because 0 over 4 gives us 0. So we are left with y over 6 equal to 1. Now 6 goes on the other side of equal to sign and it multiplies with 1 giving us the value of y as 6. So the coordinates of Q are 0, 6. Now once we have got the coordinates P and Q, we have to find out the midpoint of this line segment. So for this we are going to make use of the midpoint formula which is x, y, that is the coordinates of the midpoint, is equal to x1 plus x2 over 2, y1 plus y2 over 2. Now here we have considered the coordinates of P as x1, y1 and coordinates of Q as x2 and y2. So we are going to plug in their values now. So 4 plus 0 over 2, comma 0 plus 6 over 2. Now 4 plus 0 gives us 4 itself, and 4 divided by 2 gives us 2. Now 0 plus 6 is 6, and 6 divided by 2 is 3. So the coordinates of the midpoint of the line segment PQ is 2, 3. So let us see if it is in the options above. So here it is option A, 2, 3. Now let us move on to the next question. Two of the vertices of triangle PQR are P minus 1, 5 and Q 5, 2. The coordinates of a point which divides PQ in the ratio 2:1 are. So let us try to understand the question by drawing a rough figure first. So here P and Q are being mentioned as the two vertices of a triangle and their coordinates are given, and PQ also represents one of the sides of the triangle, and it has been mentioned that there is a point which is going to divide this line PQ in the ratio 2:1. So here we have considered the coordinates of P as x1, y1, the coordinates of Q as x2, y2, and the ratio in which the line is getting divided as m1 is to m2, that is 2:1. Now here, since we need to find out the coordinates of the point which is dividing the line in the ratio 2:1, we are going to make use of the section formula, which is x, y, the coordinates of the point which is dividing the line segment, is equal to m1 x2 plus m2 x1 over m1 plus m2, comma m1 y2 plus m2 y1 over m1 plus m2. Now in the next step, we are going to plug in all these values in this formula. So we get m1 x2 becomes 2 times 5 plus m2 x1 becomes 1 times -1 over 2 plus 1, comma m1 y2 becomes 2 times 2 plus m2 y1 becomes 1 times 5 over 2 plus 1. Now simplifying this, we get 2 times 5 is 10 and 1 times -1 gives us -1 over 2 plus 1 is 3, comma 2 times 2 is 4 and 1 times 5 is 5. So 4 plus 5 over 3. Now further simplifying this, we get 10 minus 1 is 9 over 3, comma 4 plus 5 is 9 again, so 9 over 3. Now 9 and 3 go in the table of 3. So here 3 divides 9, giving us x, y is equal to 3, 3. So these are the coordinates of the point that will divide the line segment PQ in the ratio 2:1. So here our correct answer is going to be option C, that is 3, 3. Now let us move on to the next question. The coordinates of the endpoints of a diameter of a circle are 5, -2 and 5, 2. The length of the radius of the circle is. So let us try to understand this question by drawing a rough figure first. Now here it has been mentioned that the endpoints of a diameter of a circle are 5, -2 and 5, 2. So we can see that a circle is being drawn and this line represents the diameter, and the coordinates we have taken here are 5, -2 and 5, 2. Now 5, -2 I have placed it below the x-axis, and 5, 2 it is going to be above the x-axis, because the y coordinate is negative here and the y coordinate is positive over here. Now if you see, I have drawn a line which is passing through the center of the diameter, and I have given the coordinates as 5, 0. Now how did I come to this conclusion? Because it's not been given in the question. Now to find out this coordinate, we have to look at the coordinates of the diameter. Now if you look at the x coordinates are same, which means this line is going to have all the x points on it as 5. So here obviously the center is also going to have its x coordinate as 5. So we have written 5 here. And how did we get 0 over here for the y coordinate? Now if you look at the y coordinates of the endpoints of the diameter, it is 2 and -2. So here the y coordinates are equal, but on either side of the x-axis. So this y distance is going to be 2 from the x-axis, and this distance is also going to be 2, and here also the distance from the x-axis is going to be 2. Now length and distance, when we are measuring, we do not take the signs. We take them as positive values. So this is going to be positive and this is also going to be positive. So we come to the conclusion that the center is on the x-axis with the coordinate being 5, 0. Now if we look at this, we can directly say that the radius is going to be 2. So here option is going to be 2. But let us also prove it by using distance formula, which is d, that is the distance or the length, is equal to square root of x1 minus x2 the whole square plus y1 minus y2 the whole square. Now remember that this formula can also be written as square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So here we have considered this coordinate as x1, y1 and this coordinate as x2, y2. So remember that you can also interchange these coordinates, that is you can consider this as x1, y1 and this as x2, y2. It's up to you. Now we have to just plug in the values, that is x1 is 5 minus x2 is 5. So 5 minus 5 the whole square plus y1 is negative 2 minus y2 is 2. So minus 2 the whole square. Now 5 minus 5 gives us 0. So this goes down to 0. And minus 2, they will add up together to give us minus 4. So here we get square root of minus 4 the whole square. Now the square of minus 4 is 16. So we get square root of 16. And square root of 16 is 4. And since we have considered the diameter over here, the diameter d is equal to 4. Now since we have been asked to find out the length of the radius is going to be half of the diameter, that is 4 divided by 2 gives us the radius as 2. So either by the diagram or just by looking at the x and y coordinates, you can decide what the radius is going to be, or if you want to be on the safer side, you can use this formula and confirm your answer. So here the radius is going to be 2. Now let us move on to the next question. AOBC is a rectangle whose three vertices are A 0, 2, O 0, 0 and B 4, 0. The square of the length of its diagonal is equal to. So let us try to understand this question by drawing a rough figure first. So here it has been mentioned that AOBC is a rectangle. So we have drawn the rectangle AOBC over here and the respective vertices are being marked according to the given coordinates. Now we have to find out the square of the length of its diagonal. Now as we know the coordinates of C is not given, so we can just ignore this diagonal OC. So here we will be concentrating on the diagonal AB. So AB is the diagonal of the rectangle AOBC. And here we need to find out the square of the length. And since the length is mentioned, we are going to make use of the distance formula, which is D is equal to square root of x1 minus x2 the whole square plus y1 minus y2 the whole square. Now here we have considered the coordinates of A as x1, y1 and the coordinates of B as x2, y2. Now here, since we have been asked to find the square of the length, we are going to take the square root on the other side of equal to sign so that we get d square. The square root changes to square. So d square is equal to x1 minus x2 the whole square plus y1 minus y2 the whole square. Now here just we are going to plug in the values of A and B to get the value of square of the length of its diagonal. So here we get x1 minus x2 becomes 0 minus 4 the whole square plus y1 minus y2 becomes 2 minus 0 the whole square. Now this becomes minus 4 square and the value of minus 4 square is 16 and plus 2 square is 4. So here we have written 16 plus 4 and 16 plus 4 gives us the square of the length of the diagonal d square as 20. So here our answer is going to be option B, that is 20. Now let us move on to the next question. The point on y-axis equidistant from the points A 1, 3 and B 4, 4 is. So we have been given a point which is on the y-axis and it is equidistant from the points A and B. So here we need to find out what are the coordinates of this point. So let us consider this point as point P. So P is equal to 0, y. Now the x coordinate is 0 because the point is on the y-axis. So on the y-axis the x coordinate will be always 0. So here we have the point P as 0, y, A as 1, 3 and B as 4, 4. So if we look at the point P now, it has only the y coordinate. But in the options if you see, A, C and D all three have y coordinates, but the option B has x coordinate. So initially itself we can just discard the option B. Now since the point P is equidistant from A and B, the equation we are going to get is AP is equal to PB. That is, the distance of point P from point A is equal to the distance of point P to point B. Now since we are trying to find out the distance here, we are going to make use of distance formula. So distance formula is given as D is equal to square root of x1 minus x2 the whole square plus y1 minus y2 the whole square. So let us focus on the left hand side, that is finding the distance AP. Now here we have considered the coordinates of point A as x1 y1 and coordinates of point P as x2 y2. Now we are going to just plug in their values in this formula. So we get the distance AP is equal to square root of 1 minus 0 the whole square plus 3 minus y the whole square. So this simplifies as AP is equal to square root of 1 minus 0 gives us 1 itself. So 1 square is 1 plus 3 minus y the whole square. Now once we have got AP, let us focus on finding PB. Now here we have considered the coordinates of point P as x1 y1 and coordinates of point B as x2 y2. And since we are finding the distance PB, we are going to plug in their values in the distance formula. So PB is equal to square root of 0 minus 4 the whole square plus y minus 4 the whole square. Now simplifying this, we get the distance PB is equal to square root of minus 4 the whole square gives us 16 plus y minus 4 the whole square. Now here, since we are trying to find AP is equal to PB, we have equated this value of AP we have got equal to the value of PB. Now the square roots will get cancelled from both the sides of the equal to sign. So we are left with 1 plus 3 minus y the whole square is equal to 16 plus y minus 4 the whole square. Now after this, I am going to show you two methods to solve this problem. You can choose any method which you find easier to use for the multiple choice questions. So let me show you the method 1, which is substitution. So here we have written the method 1, substitution. Now in this method, once you come to a point where the equations are equal to each other, you're just going to take the options which have been given in the question and you're going to substitute the values in the equations you have got and see which values are going to satisfy the equation. So for example, let us start with option A, that is 0, 11. So here you can see I have taken the first option, that is 0, 11. So here x value is 0 and y value is 11. So I'm just going to plug in the 11 value in this equation we have got. So 1 plus 3 minus 11 the whole square is equal to 16 plus 11 minus 4 the whole square. So you're substituting the value of y over here. So this simplifies as 1 plus 3 minus 11 is minus 8 the whole square is equal to 16 plus 11 minus 4 is 7 square. Now 1 plus minus 8 square gives us plus 64 is equal to 16 plus 7 square is 49. Now 1 plus 64 gives you 65 and 16 plus 49 also gives you 65. So 0, 11 has satisfied the equation AP is equal to PB. That is 65 is equal to 65. So immediately you'll get the correct answer, that is option A. Similarly, if this was not satisfying the equation, you could have taken the option C or option D and substituted the same way and got the answer. So this was method 1, that is substitution. Now let us look at the method 2, that is expansion and simplification. So here again I have taken AP is equal to PB and the same equation is considered over here. So here we are going to use the traditional method of expansion, that is 1 plus now 3 minus y the whole square. Now this is same as a minus b the whole square identity. So we have expanded this as 3 square minus 2 times 3 times y plus y square is equal to 16 plus, now similarly we have expanded this bracket as well, y square minus 2 times y times 4 plus 4 square. Now simplifying this, we get 1 plus 3 square is 9 minus 2 times 3 is 6, so we get 6y here plus y square is equal to 16 plus y square minus 2 times 4 is 8, so we get 8y plus 4 square is 16. Now we are going to cancel out the terms which are present on both the sides of the equal to sign and they are equal. That is y square and y square are same, so they will get subtracted or cancelled. Now at the same time we are going to add the like terms. So here 1 plus 9 we got 10 minus 6y is equal to 16 plus 16 is 32 minus 8y. Now gathering the like terms again, that is minus 8y we have taken on the left hand side. So it became positive 8y minus 6y equal to 32. Now 10 goes in the place of minus 8y, giving us minus 10. Now 8y minus 6y is 2y is equal to 32 minus 10 is 22. Now taking 2 on the other side of equal to sign, we get 22 divided by 2. So 2 divides 22, that is 2 1 times, 2 11 times. So we get the value of y here as 11. So the coordinates of point P are going to be 0, y or 0, 11. So here we got the same answer as we had got in method 1, that is 0, 11. That is option A. So here our answer is going to be option A. So these are the two methods which you can use. If you know any other method to solve this question, please drop down in the comment section below. Now let us move on to the next question. In the figure given below, points P, Q, R divides the line segment AB in 4 equal parts. The point Q divides PB in the ratio. So here it is given that these 3 points divide the line segment into 4 equal parts. So we can see this is the first part, second part, third part and fourth part. And since here it has been given that they are equal parts, we are going to take it as 1 is to 1 is to 1 is to 1. You can take any numbers, you can take 2 is to 2 is to 2 is to 2 also. To keep it simple, I have taken 1. Now once we got this, it has also been given that we have to see what is the ratio we get when the point Q is going to divide the line segment PB. So the point Q divides the line PB as PQ is to QB. So here we can see that the part PQ has one part and the line segment QB has 1 plus 1, that is 2. So the point Q divides the line segment PB in the ratio 1 is to 2. So here our answer is going to be option C, that is 1 is to 2. Now let us move on to the next question. The equation of a line parallel to the x-axis and at a distance of 3 units below the x-axis is. So let us try to understand this question by using a graph. So this line represents the x-axis and this line represents the y-axis. So here we have to find out the equation of a line which is parallel to the x-axis and it is at a distance of 3 units below the x-axis. So 3 units below the x-axis, which means this is 1 unit below the x-axis, 2 units below the x-axis and 3 units below the x-axis. So the line is parallel to the x-axis. So this is how it looks and it is 3 units below the x-axis. And since the line is touching the y-axis, the equation should represent y equal to something. And since it is below the x-axis, the equation is going to be y equal to minus 3 because it is passing through negative 3. So here our correct answer is going to be y is equal to negative 3. Now let us move on to the next question. The points minus 5, 0, 5, 0 and 0, 4 are the vertices of a triangle which is a right angle triangle, an isosceles triangle, an equilateral triangle or a scalene triangle. So in this question we have to find out, depending on the vertices given over here, what is the type of the triangle. So to solve this, I'll be showing you two methods. The first method is the usual method, that is by using the distance formula, and the second method is by using a graph. So let me start with the first method now. So the distance formula is given as d is equal to square root of x1 minus x to the whole square plus y1 minus y to the whole square. And here I have drawn a rough figure of the triangle with its vertices being labeled as A, B and C. Now using the distance formula, we are going to find out the side length of this triangle one by one, starting with the length of the side AB. So here I have considered the coordinates of A as x1 and y1, that is negative 5, 0. The coordinates of B as x2, y2, that is 5, 0. Now we are going to plug in these values in this formula, giving us DAB, that is the distance between A to B, is equal to square root of x1 becomes minus 5 minus x2 is 5 the whole square plus y1 is 0 minus y2 is 0 the whole square. Simplifying this, we get minus 5 adds with minus 5 giving us minus 10 the whole square, and 0 minus 0 is 0 itself. So the square of minus 10 gives us 100. So square root of 100 gives us the length of AB as 10. Now once we have got the value of the length AB, let us find out the length BC. Now to find out the length of BC, we have taken the coordinates of B as x1, y1 and the coordinates of C as x2, y2. Now plugging in their values in this formula, we get the distance between B and C equal to square root of 5 minus 0 the whole square plus 0 minus 4 the whole square. Simplifying this, we get 5 square giving us 25 plus minus 4 square giving us 16. Now 25 plus 16 is 41. So the distance between B and C has become square root of 41. Now finally let us try to find out the length AC. So here I have considered the distance formula and the triangle again for easy reference. So here, since we are trying to find out the length of AC, we are considering the coordinates of A as x1, y1 and C as x2, y2. So plugging in their values in this formula, we get minus 5 minus 0 the whole square plus 0 minus 4 the whole square. Now minus 5 square gives us 25 plus minus 4 square gives us 16. So the distance AC will be equal to square root of 41. Now we can see that the distance BC is same as the distance AC, but the distance AB or the length AB is not same. So this triangle has two equal sides. So this represents an isosceles triangle. So here our answer is going to be option B. But as you can see, this becomes a very long method. So let us look at the second method now. So the second method is by using the graph. So we are going to plot these points on the graph. So let me just mark those points over here. So the first point was minus 5, 0. So the first point is going to be over here. The second point was 5, 0. So it will be on the x-axis over here. And the third point was 0, 4. So it will be on the y-axis, that is over here, 0, 4. So let me join these points to show you the triangle. So this is how the triangle is going to look. So here you can see that the distance of the first point from the origin is 5. The distance of the second point from the origin is 5. So this point, that is the origin, acts as the midpoint of the side, and at the same time the third point is drawn towards the midpoint of the side. So the distance of the first point from the third point will be same as the distance of the second point from the third point. So this side will be equal to this side because the distance of both the points given from the origin is same. So immediately we can say that this is going to be isosceles triangle because two sides of the triangle are same. So you can choose any method, the first method or the second method, whichever you are comfortable with. So here our answer is going to be option B, isosceles triangle. So let us move on to the next question now. The distance of a point A from x-axis is 3 units. Which of the following cannot be the coordinates of the point A? So let us try to understand this question by using a rough graph. Now here, this represents the x-axis and this represents the y-axis, and this is the origin. Now according to the question, we have a point A whose distance from the x-axis is 3 units, which means from the x-axis, the point can be going upwards by 3 units or it can be going down by 3 units. So remember that whenever they mention a point from the x-axis, you're actually looking at the y coordinates. So let us look at the first one, that is 1, 3. So here 1, 3, x is 1 and 3 is over here. So this point is 3 units from the x-axis. So this is a point which is 3 units from the x-axis. So this cannot be the answer because we are trying to find out the coordinates of the point which cannot be point A. Now if we look at -3, -3, the -3 is on the x-axis and -3 is over here. So the point will be over here. But from the x-axis, again the point is 3 units away. So this is also a point which is representing point A. Now let us look at -3, 3. Now -3 is over here and +3 is going to be over here. Now this point is also going to be 3 units from the x-axis. So this point can also represent point A. Now the last option, 3, 1. So x coordinate is 3 and y coordinate is 1. So you can see the distance of this point from the x-axis is 1. But here they have given the distance of point A from the x-axis should be 3 units. So 3, 1 cannot be the coordinates of the point A. The correct option is D. Now let us move on to the next question. The distance of the point A, -3, -4 from x-axis is. Now remember that if they have asked you the distance of a point from the x-axis, we have to always look at the y-coordinate. So let us try to understand this by using a graph. So here this graph has x-axis, y-axis and an origin, and let us plot this point A. Here the x-coordinate is -3 and y-coordinate is -4. So -3 and -4 are over here. So the point A is going to be over here. Now since they have asked the distance of the point from the x-axis, we are looking at the height or the y-coordinate, as you can see. So the distance of point A from the x-axis over here is 4. It's not -4 because you are looking at the distance. Distance is always going to be a positive value. So here the distance is going to be +4. So you do not have to draw a graph to understand this. Just remember that distance of a point from x-axis means you are looking at the y-coordinate, and distance from the y-axis, if they ask you, then you are looking at the x-coordinate. Now moving on to the next question. The distance between the points 4 cos theta plus 3 sin theta, 0 and 0, 4 sin theta minus 3 cos theta is. Now this question is a combination of coordinate geometry and trigonometry chapters. And since here we need to find out the distance between the 2 points, we are going to make use of the distance formula. So the distance formula is given as d is equal to square root of x1 minus x2 the whole square plus y1 minus y2 the whole square. Now here we have considered x1, y1 as the first point, that is 4 cos theta plus 3 sin theta, 0, and x2, y2 as the second point, that is 0, 4 sin theta minus 3 cos theta. Now after this, we are going to plug in the values of x1, y1, x2, y2 in this distance formula. So we get d is equal to square root of x1 is 4 cos theta plus 3 sin theta minus x2 is 0 the whole square plus y1 minus y2, that is 0 minus y2 is 4 sin theta minus 3 cos theta the whole square. Now in the next step we have simplified this square root. So this term minus 0 gives us 4 cos theta plus 3 sin theta the whole square plus 0 minus the term gives us minus of the bracket. Now here the negative sign, when we are squaring it, it turns out to be positive, and then we are going to square the bracket, giving us plus 4 sin theta minus 3 cos theta the whole square. Now in the next step, as we can see, the first bracket represents a plus b the whole square. We are going to expand it by using this identity. So here we have expanded it as 4 cos theta plus 3 sin theta the whole square is equal to 4 cos theta square plus 2 times 4 cos theta times 3 sin theta plus 3 sin theta the whole square. Now simplifying this, we get 4 square is 16 times cos square theta plus 2 times 4 is 8 and 8 times 3 is 24 times cos theta sin theta plus 3 square becomes 9 and sin theta square becomes sin square theta. So this is the expansion of the first bracket. Now for the second bracket, we can see that it represents the algebraic identity a minus b the whole square. So here we have written the identity a minus b the whole square, where a is equal to 4 sin theta and b is equal to 3 cos theta. So here the expansion gives us 4 sin theta the whole square minus 2 times 4 sin theta times 3 cos theta plus 3 cos theta the whole square. Now simplifying this, we get 4 square as 16 and sin theta square as sin square theta minus 2 times 4 is 8 and 8 times 3 is 24 cos theta sin theta plus 3 square is 9 and cos theta square gives us cos square theta. Now once we have got both the brackets, let us plug in their values in the square root. D is equal to, now we have taken the square root over here for easy reference. So in place of the first term square, we have written its value, that is 16 cos square theta plus 24 cos theta sin theta plus 9 times sin square theta plus, now in place of the second bracket square, we have written its value, that is 16 sin square theta minus 24 cos theta sin theta plus 9 times cos square theta. Now here we can see that plus 24 cos theta sin theta cancels minus 24 cos theta sin theta. That is, they will subtract each other. So we are left with square root of 16 cos square theta plus 16 sin square theta plus 9 sin square theta plus 9 cos square theta. Now we can see that 16 is a common factor from the first two terms. So here we have written 16 times cos square theta plus sin square theta plus, here we can see that 9 is a common factor. So we have taken it out. So 9 times sin square theta plus cos square theta. Now here you have to make use of trigonometric identity, which is cos square x or cos square theta plus sin square x or sin square theta will be equal to 1. So basically here this bracket goes down to 1 and this bracket also goes down to 1. So we are left with square root of 16 plus 9, which gives us square root of 25, and square root of 25 is 5. So the distance between the given two trigonometric points over here is 5, which is option C. Now this was the last question for the coordinate geometry chapter, and these were the questions which had appeared in CBSE board exam 2025. And if I have left out any of the questions from the question papers, I'll be including in the playlist later. And I hope you understood all the steps and liked the video. And if you found this video useful, then check out this playlist where you'll find more examples of this kind. And if you're liking my videos, like, share and subscribe to my channel. And thank you for watching.